city, so it's a great honor, and I just want to express gratitude to all the people of Barcelona, and this is really cool. The Avalanche Summit looks like it's going to be a huge success, so really stoked to see everybody here. Today we are going to be discussing interfacing with Avalanche using AvalancheJS. And the agenda is going to look something like this. So we're going to do an introduction, very brief about who I am and some things I've done prior to being at all the labs. Then we will dig into AvalancheJS, where we're going to talk about the JSON RPC. So this is a remote procedure call, which is encoded in JSON. It's very common if you've done any other blockchain stuff with full nodes. You've probably seen JSON RPCs before. Then we're going to talk about serializing transactions. One of the big things about Avalanche is that we had this idea of subnets and virtual machines. Anybody can spin up their own subnet, which is a tailor-made network, and they can launch their own custom virtual machines. And a virtual machine, you can think of it like a state machine. So you have the state of your blockchain, you have a state transition function, you have transactions, and then you have an API that users can interact with your blockchain. So these transactions are like object-oriented classes in TypeScript or JavaScript, but then we serialize them down to basically CB58 or hexadecimal and post them to a full node. We'll go over that a little bit. And then at the end, we'll talk about some of the example scripts to bundle with AvalancheJS. So brief introduction, who am I? So as I mentioned, my name is Gabriel Cardona, and I am the head of the developer relations squad at all the labs. So along with Jovica, who is actually here at the event, I don't know if he's in this room or not. Jovica, what's up? No? Along with Jovica, who you guys may know if you hang out on our Discord channel, and along with Yulin, who also does a lot of work in Discord, and we recently had a new team member named Raj. Our team basically helps developers on-ramp into the Avalanche ecosystem. So there's really three main things we do. We maintain AvalancheJS, which we're going to talk about today. We do a ton of partner integration stuff, so dozens and dozens of Slack and Telegram channels going all the time, and then a lot of one-on-one calls throughout the week, kind of interfacing with different engineers and helping them understand our tech stack and helping them understand what it looks like to integrate their tech stack with our tech stack, answering questions, why doesn't this work, that kind of thing. And then we also go to a lot of conferences and meetups and give presentations like today, hoping to inspire amazing developers like yourself to build on AvalancheJS. So if there's anything we don't cover here, or if something's too short or whatever, just reach out to me afterwards, and there's tons of information I can point you to after this. So there's picture me. Some previous accomplishments. Something that I did in college was I was really fortunate to connect with the W3C, the World Wide Web Consortium. So Tim Berners-Lee, the creator of the World Wide Web, created an organization called the World Wide Web Consortium with the purpose of basically being a steward for different standards that are related to the web stack. So of course you've heard of HTML and CSS, but there's a ton of others. There's dozens of them. And back in the old school, before the World Wide Web Consortium, there was really a very broken and divided web. There was like the web of Internet Explorer and the web of Netscape Navigator. And different elements didn't work in different browsers, and everything was reverse engineered. There were no technical specifications. It was really quite a nightmare. And so one of the big things that Tim Berners-Lee wanted to do was to create a standards body to where these standards could be fleshed out by the different players in the ecosystem so that everybody could ultimately be on a single page. And we've seen an explosion with the modern web since we had HTML and CSS and all of these specifications. So when I was in college, I found out about HTML5. And at the time, I don't know if you guys remember 2008, 2009, but there used to be an XHTML2 spec. And the TPAC, the Technical Plenary Committee, which oversees the entire W3C, had pretty much blessed XHTML2 as being the official way forward. They thought of the web as a static web of documents, which was the way Tim Berners-Lee created it whenever he created it in the mid-90s at CERN. But as a skunkworks project, the 5 major browser vendors created something called the WHAT Working Group, the Web Hypertext Application Technology Working Group. And it wasn't officially part of the W3C, it was a skunkworks program. But these were the guys and gals who were actually creating all of the modern browsers, Safari and Chrome and Firefox, Internet Explorer, Opera, etc. And they realized that they were spending most of their time turning the browsers into an application development platform as opposed to a static document platform. So even though XHTML2 was supposed to be the path forward, HTML5 was what it ultimately caught fire. And so I was very fortunate to be a part of that group. Google actually sponsored me to be a member of the HTML5 working group, and my name is now in the HTML5 specification That means a lot to me for a couple reasons. One, the web is amazing. It's been incredibly transformative in my life, and I'm glad to know that I made some kind of impact there. But more importantly, it kind of just, the lesson I learned from this is that even if the people who know are supposed to know better, the TPAC, the Technical Plenary Committee of the W3C, made up of some of the smartest men and women on the planet, no question about it, they still were blind to the fact that the web was turning into an application platform. They were convinced that it was going to be more of the same, serving up static documents, and they were trying to put all the pieces in place to make that just a little bit better, but that's not what the world wanted. The world wanted the web to be an application platform. And fortunately, these different browser vendors recognized that, and they created HTML5, and today we have a very, very vibrant web that is an application platform, and it gets better and better every year. If you've been working in the web, which I have for my entire career, it's really amazing to think about how far things have come from just 10 or 15 years ago. It's been a true renaissance, and I think the work of the W3C has been at the heart of all of that. I got my first BTC in 2011, so a lot of people are like, if I got my first Bitcoin in 2011, I wouldn't still be working. Yeah, I understand. Just because I got my first Bitcoin in 2011 doesn't mean I got enough to retire in 2011. But the cool story here is that you guys may know Satoshi Nakamoto created Bitcoin, and then he or she stepped away for whatever their personal reasons were, and they handed over the keys to the kingdom to this guy named Gavin Andreessen, who's a really, really great computer scientist. I think he was out of Harvard. And he ultimately stepped away as well, but what he did, which was really cool, is he spun up the very first faucet. So if you hang out in a lot of cryptocurrency spaces, you know there's faucets you go and put in your address and get a little drip of some coin to on-ramp into an ecosystem. But as far as I know, his faucet in 2011 was the first one that had ever been created because cryptocurrency was still quite new at the time. And he gave away, I've always heard, I haven't got confirmation from him, he gave away over 50,000 Bitcoins, which is a lot of money today. I'm sure it's worth over $1 billion, right? And so recently I wanted to fact check that a little bit, and I went back and checked the address so he was giving out 5 Bitcoins at a time. So he set up this faucet, you could go put in your address and he would give you 5 Bitcoin, whatever that is worth today, probably a couple $100,000 or something like that. And so I went back and checked that address, which had sent me those first Bitcoin in 2011, and it had sent out over 75,000 Bitcoins, so more than the 50,000. It's entirely possible because of the way Bitcoin works. He was just sending transactions to himself or something, so there's no guarantee that he sent out 75,000, but the address from the first faucet has sent out over 75,000 Bitcoin. And I think the lesson I drew from that is sort of, he invested a lot in what he invested a lot, over $1 billion in what he believed was going to be a transformative technology. It's entirely possible Bitcoin would have taken over the world without him doing that, but I believe that was a huge catalyst. Myself and many of the people that I've talked to, some of the big players, I know Mickey is here from Bitcoin.com, and there's some serious players at Bitcoin.com who go all the way back, and all of those people that I've talked to universally got their first Bitcoin from this faucet. So, you know, would he have kept those 50,000 Bitcoins? He probably would. Would they be worth $40,000 a piece today? I'm not entirely sure, because he turned on that entire first generation of people who went out and, you know, changed the world with Bitcoin. So I think that was kind of a lesson to me of, he invested what was probably a lot in equity, but he gained a ton in social equity, and he helped catalyze something which changed the world in a big way. Next, I had a startup prior to being at Ava Labs. I actually had a startup called Bitbox, and it was doing developer tooling for the blockchain space, and that was acquired by Bitcoin.com. And so the story behind that is, you guys may remember there was a fork between Bitcoin and Bitcoin Cash in, I believe, August 2017. And before there was a total religious war, I know a lot of people find it distasteful now, but at the time, there was a brief moment in time when Bitcoin Cash was just kind of like this cool thing, and people were pretty open to it, let's say, before there was a religious war, and there is very much a religious war now, which disappoints me. But for a brief window of opportunity, there was a new flavor of Bitcoin, and so I got turned on it immediately. I got my Bitcoin Cash, I started playing around with it, I was super into it, and I had had a vision for years to create developer tooling for the Bitcoin ecosystem, and I tried to do it with something called Gitcoin. Believe it or not, before there was even a Gitcoin on Ethereum, I tried to do something called Gitcoin on Bitcoin, but it didn't take off. The ecosystem wasn't ready, and I myself just wasn't technically mature enough. It was the wrong idea at the wrong time. But I revisited that idea after I started playing around with Bitcoin Cash. And so I created an entire framework of a software developer kit built with TypeScript, very akin to what we're talking about today, which is part of the reason I got this job. And then a bunch of cloud services, and that was ultimately acquired by Bitcoin.com. And after 8 weeks of launching it, it had been downloaded in over 110 different countries. So I think the big lesson here was simply that being in the right place at the right time with the right idea can really, really be a good move. And from this, I kind of coined the term of the startup of one. So one of the cool trends we've seen in the entire, technology and startup ecosystem over the past 20 years or so is that the pace of change is rapidly accelerating, and the cost to create a game-changing idea is rapidly decelerating. So something that would have cost $1 million 15 years ago, you could do for $500,000 10 years ago, and the price just keeps dropping. And the technology that is available to us keeps getting more and more powerful. Now we have all this, the blockchain, we have machine learning and AI and all this stuff that wasn't even around 10 or 15 years ago. And so Bitbox was very much a startup of one. It was something I did out of I was passionate about. I funded it myself, and it absolutely got blew up and acquired. So I think the idea is just follow your intuition. Don't care about what other people say about it. Don't let other people make your judgments for you, and then you can be in the right place at the right time. And you can do a startup of one, 2, 5, The entire point is it only takes 1 or 2 or 3 people to really, really change the world in a radical way. Think about Satoshi. We don't know if Satoshi was a team of people. It's possibly that he or she was, but in theory, it was one single guy from Japan. So that one single person set off an entire financial revolution that we're all still benefiting and living through today, just one single person. So I just want to introduce you to that term of the startup of one, because I think it's a very powerful idea that one person can have a radical impact if they really do believe in something and they throw themselves into it. And then lastly, in 2018, I was in Milan at a technical plenary meeting called Satoshi's Vision, and Kevin and Goon, who are the two of the co-founders of Ava Labs and 2 of the creators of Avalanche Consensus, they actually woke up at 5 a.m. Ithaca, New York time and gave us a presentation on how to use Avalanche for pre-consensus on a Nakamoto consensus network. So, you have Bitcoin, and it takes 10 minutes for these blocks. And even if you have something, there used to be something called ZeroConf on Bitcoin. It was turned off, but it's been re-enabled in other flavors of Bitcoin, where you can basically accept transactions before they've settled in a block, and you have some statistical probability that they're not going to be double spent. And for a certain range of transactions, let's say $10,000 or less, the security is good enough, right? Like you can go buy some coffee, you can scan the QR code, and you can walk away without the merchant needing to wait an hour before your transaction settles. So the idea behind this presentation was, how could you use Avalanche consensus as pre-consensus in front of a Nakamoto consensus system so that you could get the benefit of this sub-second immutable irreversible finality. And so I remember leaving the meeting in 2018, my mind was pretty much blown. I really did get the implications of what Avalanche consensus were at the time. And so I've been very fortunate, based on what you saw on the previous slide, working with HTML early on in my career, working with Bitcoin, having a startup acquired in Bitcoin Cash, working with Avalanche in 2018. I've been very fortunate to witness technology go from being completely nascent to completely game-changing in just a couple of years. And so to me, Avalanche consensus really represents this coming-of-age moment for the blockchain, which is akin to Web 2.0. So if you guys remember, the web was created in the mid-90s, 94. Academics, computer scientists, hackers, professionals, these people appreciated that the web had the potential to change everything. And so a bunch of money rushed in, and we had all these crazy valuations in 1999, the so-called dot-com era. But as people started to play around with the technology, they got the sense that, wait a second, I don't think this technology is totally mature. I don't think this is ready to take on native applications just yet. And the bubble popped, and a lot of the money rushed out in 2001 or so. However, the people that saw the vision of the web, they continued working on it. And around 2004, 2005, we saw the emergence of what was called the Web 2.0 movement. And it was around a handful of technologies. The main one was AJAX, asynchronous JavaScript and XML. But we also saw the beginnings of modern CSS and modern HTML and modern JavaScript all emerge from this time. And that was when the web had a coming of age moment where it really started to be able to live up to its potential and change everybody's lives. And we saw a ton of Web 2.0 companies, including Facebook and a bunch of others that are still around today and are absolutely huge. And so to me, Avalanche Consensus and the Avalanche Network really represent a similar coming of age moment. People have understood that the blockchain has the potential to change the world in a radical way for many, many years. And in the same way that the web took the totality of all human knowledge and made it ubiquitous and available at the click of a button, the blockchain has the potential to do something similar with finances or money. It's pretty transformative, and I think it's going to have a big impact on the human condition, but it was never able to live up to its potential. Either it can only do a handful of transactions a second, so it wasn't ready for global scale, or you have to wait 6 or 7, 10 or 12, however many blocks to settle before you're confident your transaction's not going to be double spent out from under you. All of those problems go away with Avalanche Consensus. We have 4,500 transactions per second, so I think this is probably 2 to 3 times what Visa supposedly does at their max. We also have this idea of subnet, so you can launch your own entire network. We also, more importantly, perhaps have this sub-second finality. So again, as I mentioned with Nakamoto Consensus, you have this paradigm where you're stacking blocks on top of each other. And if your transaction is down here, with Bitcoin, you literally have to wait 6 blocks, 1 hour, 10 minutes each, before you're really confident that nobody's going to have the computing power to come back and rewrite some things down here and double spend your transaction out from under, or reorg your transaction out from under you. That's not even a paradigm that exists in Avalanche. When you scan a QR code and you do an Avalanche transaction, in less than a second, I think we have 3 seconds on our website, but I've certainly seen it be much less than that, 100 milliseconds, 200 milliseconds, you get completely immutable and irreversible finality. There is no such thing as a reorg attack on the Avalanche network. So this just opens up a ton of use cases, like the cliche of point of sale. So again, one of the problems with point of sale is that merchants just aren't used to this idea of having to wait a certain amount of time before they can say your transaction is settled. So buying a cup of coffee with Bitcoin has always been like this holy grail that has never fully materialized. But you can do those kinds of things with Avalanche, do things like point of sale where you scan a QR code and you walk away and you know your transaction is settled. Do things like really, really high-end distributed exchanges, which even with Ethereum had trouble competing with centralized exchanges because these centralized exchanges will co-locate hardware at different places in the world just to shave off a couple milliseconds from different web requests. And when you're dealing with 15 or 20-second blocks, much less 10-minute blocks, you can't really compete with that. But with sub-second 100 millisecond blocks that are completely final, you can compete with that. So Avalanche Consensus is very, very much a big deal. If you're not really dialed in on it, there's a reason. There's everybody here today. There's a reason our network has absolutely exploded over the past year and a half. It's because this really represents, we call it blockchain 3.0. 1.0 is Bitcoin, 2.0 is Ethereum, 3.0 is Avalanche. And we have subnets, we have Avalanche Consensus, we have virtual machines. We have a lot of things that make our platform really an entirely new paradigm. So I suggest checking it out. And obviously you are today. So some important milestones that have happened. As I mentioned, we only went live 2 Augusts ago, so I think maybe about a year and a half ago. We just recently crossed 100 million transactions on our C chain. So look at that chart. That chart is absolutely amazing, and I look at that thing once a day to give myself a nice little pep. That is truly a once or twice in a career type chart. That is an absolute explosion. And what's really exciting about that chart is if you just extrapolate maybe 1 or 2 data points from there, you're literally like at a vertical line. Like how much more straight can it possibly go from there? And this is on our primary subnet, which we'll talk about here in a second, but this is the C chain. This is an instance of the EVM where we took away Nakamoto Consensus and we put on Avalanche Consensus, so you get all this throughput and this super fast finality. And in 1 year, we did 100 million transactions, and we're getting ready to have subnets emerge, which we'll talk about on the next slide. And soon there will be different instances of subnets which are doing this many transactions themselves. So this number is certainly not done growing. I expect this will get to 1 billion transactions, and certainly in less than a year. So it's really going to be exciting to see what comes of that. You can see on the right here the Avalanche ecosystem. Again, this is just in the past year and a half, and this is just on our C chain. We have 3 different blockchains that are live on our mainnet today. This is just one of them. There's so many icons on here that it's actually kind of challenging to see what everything is, but this is all on our C chain. These are all dApps. There was a huge land grab opportunity for people who had infrastructure in other EVM ecosystems, so not just Ethereum, obviously, but Binance, or there's a dozen other, I'm sure, or even more. There was a huge land grab opportunity when we first launched to launch your existing Ethereum infrastructure or dApp live on Avalanche, because we have 100% backwards compatibility with existing Ethereum developer tooling. So if you use Truffle or Hardhat or Remix or MetaMask or any of that stuff, you simply have to add Avalanche as a new network and deploy your smart contract to our network, and it will pretty much work. There's a couple edge case gotchas, like Avalanche Consensus is a little bit different than Nakamoto Consensus in that it's quiescent and it's lightweight, and if there's no consensus messages which need to be passed around, the entire network will chill out, so you're not guaranteed to get a block on a certain time basis like you are with Nakamoto Consensus. But other than that one edge case, we have 100% backwards compatibility with existing Ethereum developer tooling. So as you can see, there was just a huge opportunity for people to either fork existing Ethereum code, or just if you have a dApp in Ethereum, to launch it on Avalanche, and has just absolutely exploded. We also had the Avalanche Rush program, which was announced back in September or October when we had our event in Lisbon during ETH Week. I was there for that as well. So it says 180 million, but we actually got very fortunate there. We allocated that 180 million in AVAX tokens, and then the price of AVAX exploded. So there was a brief moment where our Rush fund was about 800 million or so. It was close to $1 billion, including the one to the right, which is a $200 million fund we just recently launched, and then there used to be an Avalanche X grant program. Between the three, we had over $1 billion to help incentivize dApps into our ecosystem over the past 2 quarters. And that's been really, really successful. Avalanche was to target existing blue chip dApps in the Ethereum and other EVM ecosystems and get them to port over, like Aave and Curve, and there was a bunch others. And so that was really when you start seeing, well, on the past chart, when you see the transactions absolutely explode, was around the time of last September, October, when we did Avalanche Rush. That was when a lot of people for the first time tried Avalanche and got to see, like, oh wow, this is actually as good as people say it is. You click a button and things are done. I'm going to start launching my dApps on Avalanche. And then of course, now we just launched, I forget what the number is, I believe it's 190 million fund for what's called multiverse, not metaverse, multiverse, a little bit confusing. But the idea is we want to incentivize subnets. So remember, subnets allow anybody to spin up a tailor-made network on the Avalanche network, and you can launch custom virtual machines, and you can have complex validator rule sets. And so we think that multiverse is absolutely going to blow up. We've had a ton of exciting announcements just over the past couple weeks. And so these are milestones which have happened just in the last year or so. Now I want to talk a little bit about Avalanche.js. So Avalanche.js is our TypeScript library, and it's modern and it's very idiomatic. It has about, I think, today maybe like 88% test coverage. So we put a lot of energy into making sure the code is incredibly high quality. And as I mentioned, my previous startup was very similar to this, and so I've had a lot of experience doing this for maybe the past 5 years or so, just directly, so my skills were able to be applied to this very quickly. It's architected to work with the browser and Node.js, so it works on the client or the browser. You can use it in command line tools, you can use it in native apps using something like React Native or Flutter or something like that. It's a very, very diverse and expressive library. I suggest you check it out. It's got a full suite of JSON RPC calls. So this is remote procedure calls encoded in JSON. As I mentioned, if you've done any other blockchain work in your career, if you've ever spun up a full node of Bitcoin or Ethereum, you're probably familiar with how this paradigm works. Basically, there's just remote procedure calls that you can call over HTTP, primarily using POST requests. I've written a lot of REST APIs in my career. I think REST is a little bit more expressive than just straight RPC calls. So I like to wrap these things in a REST call, but you can do this with just POST request. You pass in some data and then it'll execute on the full node and it'll pass you back some return values. And we also have all of this implemented in Avalanche.js as actual functions. So, you know, you can instantiate the admin class and then call admin.alias or admin.alias chain. So just really briefly to talk about some of the things that are possible here. Today, if you've used our JSON RPC, if anybody's a developer in here, they've done like /ext/bc/x, for example, if you want to query our X chain. But that X is just an alias to a 32-byte blockchain ID. So whenever you create a blockchain ID, it creates a 32-byte identifier. And it's deterministic, so if you put in the same inputs, you'll always get the same output. But it's CB58 encoded, which CB58 is confusingly a lot like base58 check encoding, but it's not the exact same. If you use base58 check encoding, it should be pretty familiar. It's just a base58 encoding with a checksum. The slight difference is that we only SHA-256 once instead of twice, which is what base58 check does. And we use the first 4 bytes of the resulting hash as the checksum, and they use the last 4 bytes. A little bit confusing and was around before my time. I probably would have just lobbied to just use base58 check since it's kind of like an industry standard, but be that as it may, a blockchain identifier is just a 32-byte identifier, which we CB58 encode. So it's a big, long, gnarly looking string that you would never remember to be able to write down anything. So we allow you to alias that to something as simple as X, for example. So if you create your own subnet, you'll have a blockchain ID and you'll have a subnet ID, both of which these 32-byte identifiers, and you can actually alias them here so that other developers can be able to hit your full node and not have to, remember what your blockchain ID is, for example. You can also do things like load virtual machines. You can start CPU profilers. You can start change logging levels. You can do all kinds of stuff with admin. With auth, you can basically set up where you need to pass in a key value, some type of username and password with every one of these requests. It's not enabled by default, but you can do that with auth, so you can create new token, revoke the token, or change the password. I put AVM, Platform VM, and EVM on the same line here because those are the three virtual machines that we have live on our primary subnet. It's the Avalanche virtual machine, which is basically a DAG. We call it the X chain. It's for issuing assets and doing peer-to-peer payments. It's where AVAX was issued. AVAX is a fixed cap asset. There will only ever be 720 million of them. It was issued on the X chain. We have the Platform VM, which is for doing administrative tasks such as launching subnets, launching validators, launching delegators, creating your own virtual machines, all of that kind of stuff. And then we have the EVM, which, as I mentioned, is an instance of the Ethereum virtual machine with no Nakamoto consensus. Instead, we have Avalanche consensus, and you get this extremely high throughput. We also have a health API, so you can check on your node. We have an index if you want to index the blockchain. We have different data structures. We have blocks and vertices because we have DAGs and linear chains. It's a little bit confusing, but you can think about a vertex is to a DAG as a block is to a linear chain, so it's just a grouping of transactions. So you can index the entire DAG or blockchain starting from the very first transaction or block and walking your way forward. We have an info API, so you can do things like getting a blockchain ID, getting a network ID, getting a network name, getting a node ID, all kinds of different things you would want to know about the different networks or the nodes you're working on. We have a key store, so we support the SecP 256K1 curve on ECDSA key pairs. However, we consider it an anti-pattern to store your key pairs on a full node. There's always a risk that somebody malicious will hack your node and then they'll get access to your keys. So instead, you should use a library like Avalanche.js to create all of your transactions on local machine, and then you can sign them. We also have a metrics API, so you can get metrics about your full node, and then we have a WebSocket API, so you can get you can get real-time data coming off of the blockchains if you just want to like listen to it, subscribe to a channel, and then it'll post to that channel anytime anything changes. So I think more importantly is these transaction serialization. So as I mentioned, in Avalanche, a virtual machine is a state machine. You can think about it as a state machine. So it has the state of your blockchain, it has a state transition function, it has transactions, and then it has an API through which users can interact with your blockchain. And these transactions will actually trigger the different state transaction functions. That's the way to think about this. A virtual machine is a state machine. You have transactions which will trigger the state transition function. And so in each of our virtual machines, we have different types of transactions which are encoded as TypeScript or JavaScript classes in Avalanche.js. You just create and instantiate them, you pass in some values, and then you have a big object that you can then serialize into this big CB58 encoded string, which I'll convert to hex here in a second and break one down for you and show you exactly what's going on. But some of the 5 major transaction types that are available on the Avalanche virtual machine are we have the base transaction. So this allows you to consume inputs and then to create outputs. And you can have multi-sig outputs, that kind of stuff. And this is really good for peer-to-peer transactions. And the way I think about this is it's kind of like object-oriented programming. Each one of these subsequent classes extends the base transaction class and gets all of its functionality out of the box and then has their own functionality. So you can create assets. Obviously, you're going to pass in the name of your asset, a ticker symbol. You're going to pass in an initial value. So you want to say, like, my address is going to get this many tokens, that kind of thing. You can also do operation transactions. So this is a little bit confusing, but operation transactions are effectively for minting and sending NFTs on the X chain. So NFTs on the X chain are not ERC 721 compatible. Probably 99.999% of all the NFTs you're talking about in the world today are going to be ERC 721 or ERC 1155 compatible. We support those on our C chain, but it's not compatible with what's on our AVM on our X chain. This is more like a collectible type model, but you can basically mint them and send them. And then one of the really cool things we have built in at the protocol level of Avalanche is we have cross-chain swaps. So, this has kind of been a holy grail in the blockchain space for many years. There's a lot of value locked up in the Bitcoin network and a lot of value locked up in the Ethereum network. Wouldn't it be really cool if you could swap this value back and forth in some way that didn't require some third-party sort of hacky smart contract thing that's happening? You can do that, and it's built in at the protocol level on Avalanche. So we have these import transactions and these export transactions, which are supported on all of our virtual machines. And we're working on right now cross subnet asset transfers. So today you can spin up a bridge, and you can use bridges to get asset between the different subnets. That's live today. But we're working on something which is actually native to the protocol, similar to the import and export transaction, where you will be able to cross subnet swap assets. On the platform VM, we have, again, the base transaction, very similar to the last one, allows you to consume inputs and create outputs. We also have the add validator transaction. It does pretty much what it sounds like. You add a validator, you set a start time and an end time. They both have to be subsets of the full, or no, this is a validator. This is whenever you're adding a validator to the mainnet, I apologize. The subnet validator has to be a subset. So a validator you can validate for up to a year. You put a start date and an end date, and then you actually put a percentage that you're going to charge people if they want to delegate their stake to you. And basically, a validator is a full block and vertex producing node on the Avalanche network. I think today we have around 1,200 or so. Potentially, Avalanche Consensus enables millions of validators. That's a theoretical limit. We've not tested it in practice. Currently, it costs 2,000 AVAX to stake to become a validator, which we know is a relatively high number. That number will be changeable whenever we enable governance, which is very soon on our roadmap. One of the very first things you'll be able to change with governance is the amount of stake that you have to stake to be a validator. I'm very confident that value is going to go down, and that we're going to see tens of thousands, hundreds of thousands, and even millions of validators in the future, which is very important because what we're helping to do is we're building this entire censorship-resistant web. So, Web 2.0 was important, but Web 3.0 is even more important because we're taking the traditional web and we're turning it on its head, and we're putting people in power of their own data, and we're putting people in power of their own future on the web. And so by having validators there are millions of validators, even with 1,200 validators today, it would be pretty much impossible for any nation state to take down Avalanche. Because if they want to censor us, they have to take down all 1,200 nodes or a significant number of them. And they're all around the world in all of these different legal jurisdictions. And it would be very, very challenging for any one single nation state to make that happen. And so having millions of validators is going to make it that much more challenging. We add subnet validator transactions, so you can add subnet validators. We have add delegators, so you only have to stake 25 AVAX to be a delegator, 2,000 to be a validator. When you delegate to a validator, you add your weight to that validator, and then the validators are basically sampled on their weight to figure out what transactions should go into the next block. We have the create chain transaction, so this is where you can actually create a new blockchain, and so you can create different virtual machines. There's a get VM, I believe it's on the admin RPC call, load VMs, admin.load VMs, and it'll load the virtual machines that are live today. We have the AVM, we have the platform VM, we have the EVM, we have a property feature extension, we have an NFT feature extension. There might be one or two more. But you can, of course, create your own. And whenever you call the create chain transaction, you tell it which virtual machine you want to instantiate. So the way to think about it is a blockchain is an instance of a virtual machine. And in the same way with object-oriented programming, you can create a class and then instantiate it into a bunch of different instances, which are independent logical instances of that class. You can do the same thing on Avalanche with blockchains. You create a virtual machine and you instantiate it into different blockchains using create chain transaction. You can also use the create subnet transaction, and this is where you add validators to your subnet, and then you tell it what chain exactly you want to launch on that subnet. And then, as I mentioned, there's also the import transaction and the export transaction for doing cross-chain asset swaps. And then, as I mentioned, the EVM is an instance of the Ethereum virtual machine. We actually added these two transaction types to it, the import and the export, and that's simply so that you can, like I said, swap assets from the X chain to the C chain. We have what are known as Avalanche native tokens. You issue them on the X chain. AVAX is an Avalanche native token, and then you can swap them over to the C chain using these APIs right here, and you can actually wrap an Avalanche native token in what's called an ARC20 interface, and so it has the full functionality of ERC20. So a lot of people have asked, can I use native AVAX in an ERC20 contract? There's wrapped AVAX, of course, but you can also do what's called an ARC20, which is similar to an ARC20. Take an Avalanche native token and wrap it in this interface. And so I want to give you a sense of what I was talking about. This is a hex string, obviously. This isn't CB58, but you can imagine if this was encoded in CB58, it would be a different alphabet. You can convert it to hex. And so as I mentioned, a virtual machine is a state machine, and there are transactions which trigger the state transaction function. So you have a big JavaScript class that you serialize it down into this data structure. This looks like gibberish, but it's really not. So what I'm going to do is I'm going to break this down into its different components. So all of the bytes you see here, you're going to see over the next couple screens. So you can see it starts off with a bunch of zeros and then 30, 39, right? So the first 2 bytes are the codec ID. So this is in case we go to different codecs in the future. Right now we're still in codec 1, but obviously you can imagine that's going to change in the future. The next 4 bytes are the type ID. So I believe, for example, a SecP transferable input is of type 7, or I'm sorry, an input is type 5, a SecP transferable output is type 7. Their base transaction is 0, a create asset transaction is 1, operation transaction is 2, an import transaction is 3, an output transaction is 4. So every different data structure has its own type ID. Then you have the network ID. So we are a network of networks. And we have the main net, which is network 1. We have our Fuji, which is our test network. That's network 5. We have a 1337 network. We also have a 12345 network. So 00, 30, 39, if you convert that to decimal, is 12345. So this is me developing on my local machine. We have something called the Avalanche Network Runner, which is very akin to Avalanche. If you guys have developed in Ethereum, you know there's like a local development network. We have something called the Avalanche Network Runner, which I created this using that. The next 32 bytes are the blockchain ID. So the network ID allows you to route to the right network or the right subnetwork, and then the blockchain ID prevents there being any replay attacks. So if you've ever dealt with forks in any previous crypto ecosystems, you know there's this idea of a replay attack, where if the network splits in 2, you'll have assets on both chains, and unless somebody does some type of replay protection, if you do a transaction on this chain, somebody can take it and put it over on this chain and the transaction will be valid. And many, many people have lost tons of money doing that. That isn't something that exists in Avalanche. So similar to not having any reorg attacks, we don't have replay attacks, because baked into the serialization of the transactions is the network ID and the blockchain IDs. So it's going to go to the right place or it's going to fail. Next, we have the number of transferable outputs. So there's 4 bytes which tell the number. This is a very common pattern in all of our transaction serializations. If there is a variable length something, there's going to be either 2 bytes or 4 bytes that come before it which tell you the length. So in this particular case, there's 4 bytes that tell us there's one output. So we're creating one single output, and then below that you can see the first transferable output. It has 32 bytes for the asset ID. In this particular case, that's AVAX. Like I mentioned, it has a type ID, which is 7. A SecP transferable output is type ID 7. It has 8 bytes for an amount, 8 bytes for a lock time, 4 bytes for a threshold, because remember, you can do multi-sig here. So in this particular case, I'm just saying it's going to have one address and it's only going to require one signature, but you could do a 2 of 3, a 4 of 5, whatever you want to do. We have example scripts to do multi-sig, to create them and to consume them. And then you can see, similar to the number of transferable outs at the top, we have the number of addresses, so a similar pattern. This is an array of 20-byte addresses, but there could be 5 of them, 10 of them. In this particular case, the first 4 bytes are telling us there's only one. Then we have 20 bytes. One thing we did is we have what we call the well addresses. So on our primary subnet, there's several different addresses which have huge amounts of AVAX already issued to them in the Genesis transaction. So if you're doing local development, you can spin up an address that has, I think, 300 million AVAX. That's this address right here. We call it the EWOC address because the first 4 characters in the CB5A encoding are EWOQ of the private key. So we call that the EWOC address. So this is the number of transferable inputs. Again, same pattern, 4 bytes that tells us there's one, 32 bytes for a transaction ID, 4 bytes for a UTXO index, because remember, there could be multiple UTXO outputs in a single unspent transaction output. 32 bytes for the asset ID, 4 bytes for the type ID. So as I mentioned, 5 is a SecP transferable input, 4 bytes for the amount, or I'm sorry, 8 bytes for the amount, 4 bytes for the number of address indices, and then 4 bytes for the address indices. And then the last page here, every single one of our transactions allows you to write 256 bytes of arbitrary data to the blockchain. So one of the things that Bitcoin did is have this op code called op return, which allows you to write, I believe, 80 bytes of data on the Bitcoin chain. I know it's 220 bytes on the Bitcoin Cash chain. And even though Bitcoin doesn't have native token or smart contract functionality, people have realized that they can encode that stuff, asset issuance, asset changing, smart contract calls, that kind of stuff, into these 80 bytes. And then you can create wallets which take out that 80 bytes and decode it and make sense of it. That's how Bitcoin has tokens. That's how Bitcoin has smart contracts. We do the same thing, but we allow you to do 256 bytes of arbitrary data. So we think that's going to be a pretty rich field of experimentation. Here you can see, again, there's 4 bytes that tell you the length of the memo, and then there's an arbitrary length memo, which I forget what that is. I think it says from Snowflake to Avalanche, but it's encoded in hex here. And then last, there's a number of credentials. As I mentioned, we have SecP256K1 curves on ECDSA key pairs. We also have NFTs. We also have properties, which allow you to add key value pairs to different outputs. In this particular case, it's saying the type ID of the credential is 9, that's SecP, and then there's going to be 1 signature, and then we have the 65-byte recoverable signature at the end. So to go back to that first screen, whenever you see this, it looks like gibberish, but really what you're seeing is all of the different parts of that AVM-based transaction serialized into CB58 or hex and then posted over JSON RPC to the full node to trigger a state transition function on that virtual machine. So that's kind of what's going on there. And all of the different transactions I talked about, add subnet validator, import, export, all of those have this exact same pattern under the hood. And all of this is implemented in Avalanche.js. And I'm actually over time, so I'm going to really just wrap this up. So real quick, example scripts. We have dozens and dozens. I think there's probably 70 example scripts right now. Every single thing I've talked about, every single JSON RPC call, every single transaction, and every single different virtual machine on our primary subnet. We also have utility functions. So we have like create asset transaction, and we also have build create asset transaction. So an create asset transaction is relatively tedious to wire it up. You've got to know a lot about how our transaction formats work. We have a single method you can call build create asset transaction. You can pass in a couple values, and we do all this for you under the hood. And so again, we have dozens and dozens of example scripts for all of the JSON RPCs and every single one of the transaction serializations, both doing the tedious wiring it together yourself and using the higher level build method. Okay, so I think that's it. I'm over time. I don't know if we have time for questions, but I'll take questions if we do. No? No? Yeah, can we question? Anybody got any questions? What's up?
Hello. Hi. Again, thank you for the presentation.
Thank you.
I had the chance to play with Avalanche.js. Subnets are awesome. They're great. However, it was tricky to get us started. We had this really cool idea. We really wanted to get started. We really wanted to hit the ground running. For instance, you have AvaSim, you have Avash, you have the network runner. The docs are great in the website. However, the network runner that day was not working. Do you know what I mean? Like it was a little bit
Sure. So
tricky to get. Is there any work to be done to consolidate all the runners? Is there any are you guys doing anything?
So it's a good point. We used to have something which was called Avash, and that's different than the Avalanche Network Runner. It got deprecated, and basically Avalanche Networker is like version 2 of that. But by default, they use different network IDs. The Avalanche Network Runner is 1337, and Avash is 12345. So just in the Avalanche.js build that I pushed right before I got on the plane to come out here 2 days ago, all of the example scripts have been converted to work with the Avalanche Network Runner. So hopefully that won't trip you up anymore. But yeah, my team, the developer relations team, is actually hiring right now. So if anybody might want to join our team, and one of the main things we're doing with the 2 guys that just joined our team is going through all of the docs and deprecating Avash and replacing everything with the Avalanche Network Runner. So yeah, there's no question about it. We want to make everything as smooth as possible for people to on-ramp. And if you've had any problems, we have a Discord channel which you can jump in and hopefully get help. We're all on social media, but yeah, we want it to be as foolproof as possible, and that's definitely our intention. So thank you. I think that's it. I know there's other people up after me, and I don't want to hog their time. So thank you guys so much, really. Appreciate it.